Even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsies, whoopsie, whoopsie, whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsie.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
Wait, was it
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard to follow before it's too dark. Wake up, my love, please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard before long, before it's too dark. Wake up, my love, please don't give up on me.
What is up? What is up, you guys? Insert joke here for the day. 69. We are chugging through this. All right, almost 70% of the way done. Y'all have came so far. We've taught so much. You guys have been just absorbing it like crazy. Like crazy. Now we're on to databases. What an exciting development. All right, let me go ahead and adjust all my dials here. All right, let us continue with our intro here so we can get into our epic topic of the day, shall we? If you guys don't know, we are Rootkit, a nonprofit organization based in the US of A. We offer the best certs in the industry when it comes to comp sci. Don't go to college. Don't go to any other boot camp. Skip them completely. Get our cert and get a job. Get paid. All right? Don't get yourself in debt for stupid reasons. All right? Let us go and chug along here. On top of all this free stuff we're doing, if you go to our blog, we give away merch. We have our week 10 giveaway going on right now. If you go to our site and click on that link there, bam, you can enter to win. This will expire before the stream tomorrow. So this is your last chance to enter into this giveaway. We will be doing another giveaway next week. All right, next week. Alrighty. Let us move on to the next link. Oh, brain fart there, all right? In the description of this video and somewhere on the Twitch stream, there's a link to this beautiful site. We are a nonprofit, a charity. That means all your donations are 100% tax deductible. Avoid your taxes, all right? Tax evasion is here, all right? Donate, avoid your taxes, help us out, because doing things for free is a little expensive, all right? Depending on how much you donate here, you can unlock certain rewards like our epic stickers, collab t-shirt, and this epic sweater I got on, all right? 100 Day of Rootkit exclusive sweater with the logo on the back. All donations are matched 1-for-1 for the first 10,000 donations. Damn, you heard 10,000 donations. So every time you make a donation, it's like you're making twice as much. And we have pillars that we can hit along the way, like teaching for 24 hours straight, shaving my head here live on stream, and the one no one really wants to see, shaving my beard. All right, our goal is not to hit that goal. All right, I'm gonna lose all my powers, and we don't want to have that happen now, do we? Alrighty, that's all I got for the intro. What questions do y'all have so far before we hit into our topic today, which is discussing and talking about and teaching some databases? It's going to be a fun one. Also, if you're a Patreon or Discord premium member, I am in the events chat over in Discord, so you can go ahead and hop in here, and then you can just chat away. You don't have to just type. All right, you don't have to just type. All right, let us see here. Sunday. Every Sunday, our chill Q&A day. That's coming up. So any questions you have from any of the previous days, make sure on Sunday you ask, all right? You ask, bring those questions up, prepare them, because Sunday's as short or as long as you guys want, all right? Short as long as you guys want. We don't cover anything new that day. Alrighty. I don't see any questions rolling in, so we're gonna go ahead and chug along and start. Now, I put some links into the 100 Day of Rootkit chat for you guys to go to and download some stuff. So download Postgres, all right? Postgres, go in and download this. It's just called postgresql.org/downloads. And then you guys can download something like dbeaver, all right? What these are is Postgres is one of a million different types of SQL style databases. All right, it's just free. Another one that you can do is Maria, which I personally would prefer. All right, there's Maria also. dbeaver is just a GUI for interacting with databases. All right, it's just a GUI because by default the databases will not come with a GUI. They're not at all. All right, you have to have your own GUI. All you get is a CLI. All right. And the CLI is, you know, doable, but look, I like pictures just as much as the next person, all right? So GUI power. dbeaver's free. There's lots of them out there available. All right, so you guys need to go download those. when you download those, you can go ahead and start Postgres. All right, start Postgres. How you can do that is you're just going to get a CLI. So if you type in PSQL, you'll see this thing called the SQL shell pop up. All right, when this pops up, this will be starting your database server. You got to put some information in here. By default, you can keep it by the default. So when it asks for server, in the brackets here show the default server location, which is localhost, which is your computer. All right, we're going to keep that the same. Press enter. The database is called Postgres. All right, that's the default one. Whatever, we'll keep that the same. That's the default port for Postgres, so we'll keep that the same. Default username. All right, we'll keep that. Oh no, I just fat fingered it. So let me close that and Postgres and reopen this up. Enter, 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 enter. You can press enter and then password. You can put in a password or not. Just you can put in password. So I just made a password called password, and there you go. The database is live. It's working. It's functioning right now. You will only get a CLI here. We're not going to be talking too much about the CLI right now. We're going to be using a GUI. All right, we're going to be using a GUI. Now, what is SQL and what is Postgres? What's the difference to Maria? And I'm just so confused. What is a database? Great question. Well, we kind of showed off yesterday that pretty much anything can be a database, including your text files. All right, your text files are as much as a database as everything else. Just somewhere you're storing data. All right, an Excel spreadsheet could be a database for you. All right, I know it is for a lot of governments. All right, more than you would happen to like. Those are the default databases for keeping information about your employees. All right, so if we look up the word database, let's see here. A database is simply an organized collection of structured information or data, typically stored electronically in a computer system. All right, in a computer system. Again, anything that is stored, that is data. So text files are valid databases. CSV files, Excel spreadsheets, your Google Sheets, those are all valid databases. They can all be used to store data, and you can recall data from them. All right. There's nothing really different about bigger databases like Postgres or Maria, etc., etc. They're all going to have a file that saves all the data to it, right? Just like your text file. They work off the same mechanisms. There is nothing special or crazy they're going to do. What you get when you use a database is speed. They're going to run a lot of processes in the background for doing indexing, allowing for searching of that data. Maybe they keep some of it in memory instead of on disk. All right, you get extra functionality, which can empower you in how you can recall data, because recalling data from a disk is kind of a slow process. You guys have seen, you have to sit there, you have to open the file, and then you have to read the stuff from the file, then you have to close the file. Databases by default, a lot of them will have mechanisms to keep stuff in memory at all times, depending on how often it's recalled. Additionally, they have pre-baked in ways to sort your data in a efficient manner that will allow for potentially log of n queries. Remember binary search trees that we talked about? Databases will employ techniques like that to organize your data, so that way it's very fast to query. Again, at the end of the day, it's all usually going to be stored as a file that you can look at. All right, no different than your text file and you writing stuff down there, but you're getting all this extra functionality, which can make it very, very powerful. Any questions so far before we chug along? All right, let us chug, shall we? All right, so SQL is a type of database. There are lots of SQL databases, all right? Also known as SQL, all right? Also known as SQL. SQL stands for Structured Queried Language, all right? This relies on structured data. All right, SQL particularly is in reference to the language, but it's also in reference to a certain type of database, which requires structure, right? It requires structure, which means that you're not just throwing in random data just as you like. You can't do that by default, all right? You have to tell it beforehand the exact structure you're going to use. Are you going to have first names, last names, credit card information? You can't just have like a post. You need to say what from our tweet example yesterday, you can't just say a tweet. Like, what about that tweet? There's going to be a text message attached to it. How about who tweeted it? How about when they tweeted it? All right. You need all of this thought through beforehand. All right. You can't just add it. All right. You can't just add it. You have to state it all beforehand because it relies on structure. Additionally, these databases will allow for typically relations. What does relations mean? Relations means that I'll have for simplicity's sake, a file for users. And in this file, I will keep a list of all the users that have signed up on my platform, when they signed up, information about them like their email, the first name, last name, etc., etc. And then I'll have a separate file that's maybe for all of the tweets ever. These are disconnected by default. But what you can do with a relational database is you can use the special ID that you can give users over with the tweets in order to imply what user tweeted without keeping all the information about users also in with the tweet. All right, also within the tweet. So what some people might do by default would be, Elijah posted this tweet. So in the tweet file, they'll say the user Elijah posted this tweet at this day, and this was his like profile picture, etc., etc. With the relational databases, you don't need to do that. All you do is kind of like a pointer in C that we talked about. You will leave an ID, which is a pointer in this file that will say, look at our users file and see on line, 3. See the information there. That's the user that tweeted it. All right, let's see if there's some good pictures here to kind of show off what we're talking about before we dive into our stuff here. Let's look up relational database. There we go. So this is a good example right here. Let's see what other examples there may be. These are all great examples. Or this, because you guys have all taken classes, right? And those classes will have ID numbers attached to them, right? College, you got English 101, but they'll not just be called English 101. There will be, an ID attached to that class. All right. That ID is a pointer, all right? A pointer to information about that class. All right. So that's what you take advantage of in relational databases here. So you'll have, for example, 3 different tables here. In our simpler example before was like 3 different files, where 1 is going to be for all of the students' information, 2 is going to be what students are taking what classes, and then table number 3 is going to be listing all of the courses that are available. All right. This middle table is sometimes a little confusing to some people at first because its whole job is to connect things together, right? Is connecting things together. But as you can see, I don't need to put all the information about the student because this is a small table where we just have the student's name, but we could be including, their email, their address, etc., etc. We don't want to copy and paste that information everywhere because, again, we like things to be dry. If a student updates their information, that means we need to change it everywhere. We don't want to do that. We want to just change it in one place, right? We want to be as lazy as possible. So we're going to put it all in one table, slap an ID in front of it, and then whenever someone wants to refer to this student, they're just going to refer to the ID. All right, so you can see here, student with ID 1 has classes with 1, 2, and 3. ID 1, 2, and 3. So that's Sam. Sam here is student ID number 1. So Sam has classes for the course ID of 1, 2, and 3. If we look over at courses here, you'll see Sam is enrolled in the SQL Server, the ASP.NET MVC class, and then the MongoDB class. All right. This is the way that databases are used. There's nothing fancier than this. This is literally it. All right. It's basically Excel spreadsheets on steroids. All right. It's literally Excel spreadsheets on steroids. There's no better description than that. So if you are very fond to Excel spreadsheets and you've used them a lot, this should be really, really easy for you to understand and start using. Any questions on this before we chug on forward here? Out of all the rootkit streams days, this is my favorite one. Why? Because you like because he likes Excel spreadsheets. This is all we're gonna be doing today, you guys. Is gonna be talking about basically Excel spreadsheets. All right, let us continue on, shall we? Or is it because it's the day? Oh my, you sick man. I should have known. All right, let us continue on here. All right, let us continue on. So again, everything's the wild, wild west in the programming world. There are lots of different SQL databases. All right, SQL in reference to it's a database that requires structure. It's usually in reference to a database that's a relational database, aka requires structure, and you must say what the structure is beforehand, not after the fact. You must know what data you are going to be receiving and storing. All right, everyone and their dog has their own version of doing this concept for a database. So there are lots of different SQL databases out there, and I mean lots of them. All right, lots of them. Each one has pros and cons to it, but that's like on a super like senior level. At your level, at entry level, they're all the same. All right, don't worry. They're all going to work equally for you at any capacity. One of the biggest ones used to be MySQL, but MySQL recently, I can't remember if they went back on it. It was open source and free, but I believe they made it closed source. So now, in response to that, I can't remember if they open sourced it again, but in response of them going closed source, MariaDB was made, which is a fork of MySQL, which means it's a copy of MySQL. They literally copied the entire code base, and then they kept producing it their own. Like I said, copying, pasting, stealing, theft, criminals, it's the core of the developer community. So if you're a criminal at heart, hey, this was meant for you. All right, this was meant for you. So MariaDB stole everything legally because they can fork it, all right? And then they kept producing it with their own concepts on top of it. There's other stuff like Postgres, right? Which you guys also downloaded, which is a pretty popular one, right? Pretty popular one. There's MySQL, Maria, Postgres. I feel like I'm missing some other ones. AWS, Aurora, God, I can spell it, is their own version of it, right? Their own concept of it. And I'm pretty sure Google has their own version. I'm pretty sure Microsoft probably has their own version. Pretty much everyone has their own take on it. There's lots of these. There are lots of these SQL style databases, all right? What you use doesn't matter unless you are at more of a senior level and you know exactly what pros and cons you're looking for. Besides that, does not matter, right? Does not matter. We're going to be using Postgres at first because it was requested by one of you guys. And then we might switch and use Maria. I did post the link for Maria a little later. I personally prefer Maria MySQL over Postgres, but that's for other reasons. All right. The functionality that we're going to use is pretty much going to be the same for both. All right. Any questions with that before we chug along? The most equivalent comparison I can make is like web browsers. Web browsers are things that allow you to access the web and render pages, right? Everyone and their dog at one point used to have their own version of a web browser. There's Chrome, Safari, Opera, Firefox, old back in the day like Netscape, Internet Explorer. There's probably others that I'm just not that familiar with. They all do the same thing, right? Slightly differences on some of them, all right? If you are a beginner to the internet, like maybe your grandma, it doesn't matter what they're using. They just need to use something. Once you're a pro avid user of the internet, then you will understand really the pros and cons of using something like Internet Explorer compared to, I don't know, Google Chrome, which is the best internet browser available, period. At least for now, all right? At least for now, in my opinion, all right? So let us continue on here. So once you got your Postgres server up and running, which we went through the steps here, basically just press enter, 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 enter. Edge and Chrome are the exact same thing. They are both Chromium browsers. They both use Google's tech, all right? That they look the same for a reason, because they are the same, all right? It's funny because Microsoft literally dished in and said, I guess we're just going to use Chrome stuff. You can make your own Chromium based browser if you just search up Chromium. There you go. Search up Chromium, you can download Chromium, and then you can put some extra stuff on top of it. Well, better for me because all of my accounts are Microsoft for my university, but it's basically the same. It is the same, period. It is literally the exact same browser. Yeah, Microsoft is doing a good job at getting its little greasy hands deep in the university and in gov systems right now. So we'll see. They're doing a great job at slowly taking over Google's threshold on the internet. They've been sleeping. I mean, they got a bunch of lazy, crappy devs at Google right now, so they've been sleeping too long. They're getting slapped in the face hard. So let us continue on here. This is up. Great. We can interact with the CLI here. Let me see if I type help. All right. It gives me some help commands here that I can use, like / ? All right. And I can see more help commands. So again, your knowledge of CLIs pretty much will come in handy anywhere. And as you can see, there's lots of stuff you can do with the CLI here. But even I don't like messing with the CLI sometimes when I don't have to. All right, like right now, databases. They're very visual. I don't want to mess with this crap. I want to see something pretty. So let's load up dbeaver. All right, let's load up dbeaver. You don't have to use dbeaver. You can use any type of database viewer you would like. All right, dbeaver is just free, so you can just boot that up and run it. So if this stops taking its sweet time, we'll be able to connect to this database. So you guys are going to be, I think, a little bit out of luck here because I don't think I can make this any bigger. Let me see in preferences here, user interface. Appearance, dark mode. Yeah, y'all are out of luck. All right, y'all are out of luck. So unless I can I? Here we go. We're gonna do some. Oh boy, here we go. Zoom. Wait. Why is it not working? Hold on. What? Oh. Hopefully this doesn't mess up my stuff, so I'm gonna be screwed later. Oh yeah, there we go. We're just gonna manually slowly zoom in on this. All right, lightning speed right now. Call me Lightning McQueen. There we go. All right, I'm gonna have to pay attention to my screen. All right, that's about as good as it's gonna get for y'all. All right. All right. So I just can't move this window around. Hopefully I don't. But let's connect to the database. I connected earlier, so I'm going to go ahead and delete this so we can reconnect. Okay, please don't. There we go. Don't look in that folder. All right. Just keep your eyes away from it. God, what's wrong with you? Can't a man have some privacy? All right. So when you click on this button up here, I guess I should explain. So this is what it will look like by default for you. Most likely, the side panel is going to be your database navigator. It most likely won't have any databases in it. How we can add our own database is going to be pressing this little plug button here with a plus. Right? This is making a new connection to a database. If we click on it, you're going to see there's going to be a lot of choices. Right? It's going to be typically on the popular page first, where you're going to see lots of popular databases. And here, you're going to see some more databases like SQLite, which is very commonly used in lots of platforms. And I was debating on using that one today also, because it's pretty much built in as like a pip install package. There's the Microsoft's version of an SQL database, Oracle's version of it. Well, look, IBM's version, like I said, everyone and their dog has their own version of a SQL database, all right? So we used a Postgres one, so we're going to click on this Postgres logo here. Then we're going to go down to the bottom and click on Next. Here is going to be the information for you to fill out to connect to your database. So host is going to be the domain it's on. Ours is localhost. What port is it on? We use the default port, and this is the default port also. All right. What database are we connecting to? Well, we use the default database, which is called Postgres. If you want to know where all this information is, if I can scroll up to the top here, it's all right here again. All right. Localhost, Postgres, here's the port. When it asks for username, our username is Postgres. So if we go here, username, our username is Postgres. And then for password, I put in the great password called password. All right. You don't see the password show up on here. That's default security, but it's still entered it in. So in here, I can just type in password because that's our great password. No one will ever guess this. All right. It's the most secure password you can have for a database, right? That is all you got to do. These are a bunch of extra options you have here. Don't worry about them. All right. Don't worry about them. All you need to know is your host, the database, the username, and the password. And this is pretty much identical for every database. All right. When we click on finish, this will go out and try to connect to the database. And if we try to open this up, there we go. It opens up successfully. And this icon here, it's very, very small, but there's a little green check mark by it. All right. There's a little green check mark by it, which means we connected successfully. There's going to be some folders that you see. This will change and vary on what database you're connected to. All right. Some will have more folders, some will have less, some will have them slightly named differently. All right. The important concept is you usually have one that talks about the system information, which is basically the settings for your database. One that's going to be administrators or roles, which is going to be for the accounts. And then there's usually going to be one called databases, which is kind of weird because you have a database, and inside that database, you can have more databases. All right. So that's what we have right here is we have a server that's a database server, and inside there we can have more databases. All right. So by default, we have a database called Postgres in here. It can be called whatever you want. All right. It's just like a variable. All right. It's just a database with some type of name. We just called it Postgres by default. If we open this up, then you're going to see some more folders in here. You're going to see some more folders in here. Folders for like roles. So this is more users you can have and set up for access to the database. Some more system information, stuff about storage, extensions, event triggers, schemas. All right. Lots of weird things. Lots of weird things. Schemas are what we're interested in right now. Other people will just straight up say tables. They'll straight up just say tables They call it schemas, and they have a slightly different layout than some other databases will. So schemas is what we want to go into. Schemas are the scheme of our database, right? You know how you think of a scheme, you draw up plans, right? Same thing here. This is where you draw up the plans for your database and where everything lives, right? Where everything lives. So let's go ahead and open this up, and you can open up public, because I think these are all just going to be different schemas in here. All right. And then in here is going to be our tables. Your tables are effectively the different files that you want. The different files that you want. So if you want a text file per se to store user information, you would have a table called users. Then you make another one for like products you want to sell, and then maybe another one for transactions. All right, to keep a log of all of this information. You want to avoid tables that do too much. You want to keep tables as simple as possible to one core subject, like users. It should just be information about the users, not about what the users have done, not about what they've bought, not about anything extra like that. It should just be about the users. You can make another table that talks about, you know, what they've done, and another table about what they've bought. All right, it should be very, very specific. Let's go through some concepts, right? Let's go through some concepts. In dbeaver, if we right click on table, we can create a new table, right? When we create a new table, up here at the top, we can give the table a name. So let's give this one a name. Let's call this our users table, right? So we'll call this our users table, and we'll give it the name users. Below that, you'll get some extra information here. We don't need to fill out any of this stuff. And this is columns, all right? Below this is going to be our columns that we want to have. This is just like a SQL spreadsheet, or not a SQL spreadsheet, an Excel spreadsheet. So for all of those that have the mercy of not knowing what a Excel spreadsheet looks like, we're gonna look them up. Spreadsheet. I'm gonna move this stuff around. Open a new tab, and let's see, let's go right here. Oh yeah, data. This is a spreadsheet. Hopefully this isn't new to you guys. I really hope this isn't new for you guys, because I'm not going to be going over what a spreadsheet is, right? The spreadsheet will have a name. This one is called, looks like test tac1.csv, right? It has a name. A single spreadsheet like this is equivalent to a table in a database, right? So ours would be called users, right? Ours would be called users. Forget about the little tabs here at the bottom, because technically it would be more applicable to this would be our database, and each tab down here would be tables. Forget about that. We're going with a simpler approach, all right? This is going to be users. Inside of here, there are columns, right? There's a column here for files. So this is the name of the file, all right? There's another column here for loudness, right? How loud that file is. Then another one for range, true peak, you know, a bunch of other stuff here for music stuff, all right? That I'm not too familiar with. But it's a database. This is the type of structure that you need to have in a SQL database. You must predefine every column that you want beforehand, right? You must know what columns you want beforehand. So for users, for example, we might want a column for first name, and then another column for last name, and then another column for emails, all right? This structure you see here is exactly what we want. There's also something hidden in here. If I tell you to look at line 15, what did you just do? You went over here and you said, I looked at line 15. This is an identifier, all right? An ID for the line, all right? This is an ID for the line. This is a unique ID that every line will have, and no line will ever have the same ID, right? We need those also, because how are you supposed to potentially refer to other people in other tables or etc. if they don't have their own ID attached to each other, right? This is how you get your IDs created whenever, I don't know how much exploring you guys done in your off time for programming, but when you generate your ID or look at your Google ID, etc., this is basically what they're using it for. They have an ID just like this right beside you, and that's the ID that you're able to see, right? So let's go back to dbeaver here, and let's make a table for our users. So if we right click in the column section here, we can create a new column. Our first column should always be, and I need you guys to pretty much just brute force remember this. By default, you should always have an ID column in your table, right? By default, always have an ID column. There are situations where you don't need them, but I'm telling you, when you're new, just have an ID column by default. It's going to be best for you overall, all right? So let's go ahead and make an ID column in here. Next is going to be the data type. Remember in C where we had to be very explicit with what type of data we wanted. We need to say if it was a char, a boolean, an integer, etc. Guess what? Databases are usually written in languages like C or Golang, where you need to be very specific about what you're doing, potentially about the data types, and you want to be as efficient and fast as possible. The whole point of databases is you want to be fast and efficient, more fast and efficient than using something like a text file. So in order to keep things as small and efficient as possible, you must tell it what data types you are going to use. All right. So varchar means a variable length char character, aka a string. Why do they didn't call it a string? I'm not quite sure. I'm gonna be honest with you. All right, but it's just a string. We want an integer value. So what we can do is, I don't want to go searching through this thing, so we can just type int, or I guess we just need to do I, and you'll see there's int here, right? There's a bunch of different types of int. The number at the end of int tells you how many bytes are going to be used. So int by default, I don't know how much that's going to use. I'm going to assume maybe it's 4. I'm guessing it's going to go off what the operating system's default is, which Windows 64-bit is going to be 4. There's also 2, which is going to be 2 bytes, and there's an 8 here for 8 bytes. You would want to use the one that corresponds with what you are going to need. And you'll also see there's another one here spelled out, integer. Why? I don't know. I swear there's lots of duplicates in here, right? There's lots of duplicates. Identity for Postgres, I'm gonna be honest, I have no clue what it's for. Not null. This means this value can be potentially empty. This value can be potentially empty. We never want this value to be empty. This value should always be full of some type of data, right? Because it's going to be equivalent to our line numbers, right? Equivalent to our line numbers. So we're going to click on that to make sure it's not null. And then we can go and click on OK. All right. Pretty sure there's some stuff we're missing on this, like defaults, but we'll go do some Googling to figure it out. All right. When you make some columns in here, none of it is saved or persisted. As you can see, it's all red over here because it's not saved. There is a big old save button here at the bottom, which you guys cannot see. So let me move this up a little bit. There's a big green save button here at the bottom, all right, that you guys can click on in order for everything to get saved. Let me see if I can shrink this up a little bit. There we go. Also, Control S works, right? Control S works. So if we do Control S, you'll see this comes up. This is SQL. This is the structured query language. This is, the actual language you use when you're talking to the database. You will have to use this language when programming, potentially, right? In your program, this is the commands you would send. This is technically another language you are learning, all right? So you've learned Python. You learned some C. Now you're learning some SQL, which is your third language. This language is not like the other two. All right, this language does not have potentially all of the features that the other ones do. It depends on the database, but it's more so for retrieving data intelligently. All right, so it's slightly different than the ones that you've seen before. It is set up to be as literal as possible. What do I mean by that? Using real world verbiage. So you can see here, this one says create a table. What table are we creating? Well, it's underneath public, so this is basically your relative path here. So underneath the public schema, we want to make a table called users. And inside of that table, we want a column called ID. It's going to have integer values in it, and it's not supposed to be null. Right? It's not supposed to be null. I fell behind trying to install the software. Could you show how to make the actual database again? Sure, 1 second. So all we got to do is then click on persist. All right. So every time you do Control S or press on the save button down here, it will bring up that prompt that will show you the SQL command it's going to run, which is great because one, it's just making sure you actually want to go through with it. But two, it allows you to learn SQL while you're actually running SQL, right? So you can visually see what's going on, you can see the code, and so maybe you can start messing with your own hands and typing out your own scripts. All right, you got to click on persist to actually persist it, and now you can see everything here went from red, and from red went back to just being normal colored. All right. If you guys have questions about that, please ask. For Matthew, you need to make sure you start the shell. So this is going to be, if you search PSQL, you're going to see the shell pop up. When it pops up, pretty much just press enter, then press enter again, then press enter again, then press enter again. And on the password section, you can either just press enter or you can type in a password. I just typed in the password. All right. Pretty much you can just press enter all over. Just constantly spam it until you see a command prompt like this, and then you're done. It's all set up. All right, I don't see any other questions right now, so let us chug along. Hold on, let me look in here. Nope. All right, so let us chug along. We made ID, but we need some more. We need some more here. All right, so let's do a right click here and create a new column. And this one, instead, we're going to do something like first name. So first name, and I'm going to use snake case. You can use whatever you want. This is going to be a string. So we're going to do varchar, and this can be null. All right. Then we're going to make another column, and this is going to be our last name. All right, varchar, and then we're going to make another. All right, good. I thought I misclicked there. We're gonna make another column. Maybe this is for the email address. All right, for their email address. There we go. And let's do Control S to save. And here are the commands. You guys can learn SQL commands right here. All right. Just so you know, databases will have different commands. All right. Postgres has slightly different command structures and commands than MySQL, and I'm very familiar with MySQL, right? A lot of databases by default will be MySQL based command languages, all right, which is just ever so slightly different, all right, than Postgres, right? And you'll see that even featured when you go searching at, like, I don't know, AWS Aurora, which is their own version of a SQL database. And their big advertising point is they made a new database, but they used it so it's fully compatible with the MySQL language and the Postgres SQL language. All right, you can choose one or the other because those are pretty much the top two of what people know. All right, I'm over here in the MySQL group, so we're out of my comfort zone right now. All right. But don't worry, we aren't going into anything too complex, so we'll be able to get by. We'll be able to get by. This is cool and all. We've made a database. we've made a table in the database for holding users. Cool. How do we put some users in here? All right, great question. Using programming. We're not going to use programming right now though. All right, we're going to hand jam these. All right, we're going to hand jam these. There's a tab right here called data. If we click on this tab, this is all the data in our database. And you can see it's in a Excel sheet-like format where there's ID, first name, last name, and email. If you double click on any of these items, it should let you enter something, and it's not, which is fine. There's another way we can go about doing this. All right, but data is going to allow you to view and see the layout of your spreadsheet effectively right here. All right, there's one thing we want to do, because I'm pretty sure it's not set right now, is our ID, which is effectively our line number per se. We want it to automatically fill in, automatically increment with every single new line. We don't want to have to memorize ourselves what line number everything is, and we want it to be unique every single time. So we need to figure out how to do that, because I didn't see any options in this one for that in particular. So let's go to our Googles, because anytime we have questions, we should be going to Google's first, right? So let's Google here Postgres, because that's what we're using. ID, because we're making ID, and that's a very common thing to do. And you'll see here in my recommendations, auto increment is one of the first ones that come up because it's a very popular thing to do. And let me go ahead and like resize this so you guys can see the whole page. There we go. We can see this is how we created the table before, and that's how we created the columns. And ID, so it's something called serial. It looks like the serial data type is what we want. The serial data type has data type small serial, serial, and big serial. So there's 3 different types. All right, merely notations and convenience. These are similar to auto increment property that some databases have. All right, sweet. So what does that mean? This is wrong, and we need to change this data type here to serial. All right, so once we change that, let's do Control S to save. We'll click on persist, so you can see this is how you can change a table. And serial does not exist. How are you gonna say what? Isn't that the most fun? Why, Google? Why you gotta fail me now? All right, let's go back to Google. Please forgive me. Did I say something mean to you earlier, Google? This one says to use serial also. So last just effort, let's go ahead and delete this ID column. So we just delete it by clicking on it and then pressing the delete key, or you could right click and click on delete. And then let's remake the column, call it ID, and let's change this to serial. Okay, save, persist, of relationship user, column ID of relationship user already exists. Okay, then let's go over to this. What do you mean the relationship already exists? Wait, is it happy now? No, it's all red. Oh, I hate databases sometimes. It was a dangerous game doing a new one. All right, doing a new one. All right, let's do a refresh here. I don't see what it means by there's a relationship set up, because we didn't set up any type of relationship. So let's go back here, create ID. Please be nice to me. Now a different error, God. Not null. Okay, I'll do a not null. Okay, it just magically works this time. All right, we're not gonna question it. We're not gonna question it. All right, sometimes this just happens. Sometimes it just doesn't work. Sometimes it does work. All right. So this is now supposed to auto increment for us, which is going to be really nice. So let's add some data in here, shall we? So we know in the data section, we can't really just double click and add data. So what we can do is typically if you go over here and right click on your table. So our users table here, let's go in and right click on it. And there will be a section here called Generate SQL. SQL is the way you can interact with your databases, right? This is for interacting with everything, creating stuff, deleting stuff, inserting stuff, merging stuff, searching for stuff. Everything you can do is done with SQL, right? Is done with SQL. We want to add new data. So to add new data, we need to use an insert script, right? We need to use an insert script. Luckily, dbeaver here will auto make us one. When we go over to generate SQL, we can go to insert here and click on it, and look at that. It has generated SQL for us for inserting data. This is the format for it. So we must copy it. So let's go ahead and click on copy. All right, and we have to run our own scripts. So how we can go about running our own scripts is there's a big old SQL tab right here that we can click on, and it will give us a command prompt-ish page here where we can paste that code, So here's some SQL we have. All right, let's break it down a little bit. Insert is our first big command we're doing. So we're going to insert where? We're going to insert into this table, public.user. So that's schema.user, which is our table. All right. What do we want to insert? We want to insert a first name, a last name, and an email. But where's the ID? Well, remember, we just change it to auto increment to that serial value, which means it's going to automatically make that data for us. We don't have to do it. The database is going to manage it on our behalf. All right. So now we can enter in this data. All right. So how do we enter in? We call a function called values. And in here, there's 3 items. These 3 items, one for one, sync up to this item. So the first item, first name, is going to be right here. The next item, last name, is going to be right here. And the next item right here for email is going to be this one. So let's go ahead and go to first name, and let's do Elijah. And then, let's go to the next one, and we'll do Harmon. And then we'll go to the next one, and we'll do eharmon@rootkit.org. All right. Once we have this all set up, we can click on the execute button. All right. There's 2 here. We can just click on the first one, execute SQL statement. So let's click on that, and we've done it. All right. If you can see here, it ran this query, it updated 1 row, and it gives you a start time and a finish time. As you can see, it was very, very fast. All right. It was very, very fast. And the cool thing now is if we go back to our table over here, and there's like tabs basically here for everything that we open up. If we go over here, at first you might be wondering why there's nothing in here. That's a great question. Everything is very manual when it comes to the databases because there could be lots of data on it. And so you don't want it auto refreshing in the backend because it could slow down your database and cause all types of issues, particularly on RAM because you're querying the database, bringing up all this data. So you have to manually refresh a lot of times, right? So if we look all the way down here to the bottom, there's a refresh button. There's also, you can set it up to auto refresh if you want. All right. I'm not, you guys can though. If we press the refresh button here, you'll see, we stored some data in our database, here. So it's pretty much that easy to utilize a database, right? It's nothing fancy. It's nothing super difficult at first. You can set up a database wrong in the sense of what tables you have and how you're storing your data, but to actually store and make tables is very, very simple, right? Very, very simple. So we can resize these if you would like to see everything around. Like I said, it's basically an Excel spreadsheet, this layout. It's basically the equivalent to an Excel spreadsheet. So much so that you got little drop downs here for filtering. You can order things by last name, by first name, by email, by their ID. You can do a lot of stuff here. I'm gonna move the ID to the front. All right, you can do a lot of things here. All right, now if you realize after the fact that, oh crap, I wanted to also keep like created time here, so I know when a table was created, or maybe like IP address, so you know where this user was originally created. Why would you want to know someone's IP address? Well, you're automatically going to get everyone's IP address that ever connects to any of your systems. All right, everyone logs IP addresses. Why? For hacking sakes, right? So you know where someone is at. So if they claim their stuff is compromised, you can potentially see if they're coming from the place where the account was really made, or if they're coming from somewhere else. How does the bank know that something suspicious might be going on with your cards or your sign-in or your card? They track everywhere you go and what transactions you make. All right, and they know if you, for some reason, end up in Timbuktu tomorrow, they might be a little fishy. Same thing with all of your providers. They track it for the same reason. And there's lots of services that can help with that, with your security by default, as long as you're tracking the correct data. So let's go ahead and modify our table to add a couple extra columns here. So let's go to the properties section. So we were in data. Let's go to properties to see the properties of our table. Let's create some new columns here, like, I don't know, created time. And let's see if there's a data type for time. Let's type in T, and look at that. There's one for time, one with time and the time zone, time without the time zone, time stamp. There's a lot of different types of times out there. We're just going to go with the basic time, but most likely if you're going to make a bigger application, you want to incorporate time zone, right? It's pretty much a necessary thing you need to do, because 7 p.m. for me is going to be different for everyone watching the stream, because like we're international organization. All right, 7 p.m. you got to know 7 p.m. what time. All right, you got to be tracking those time zones. So let's go ahead and click on OK for that. And maybe we want to track something else, like I don't know, IP address. So we can do that too. All right, that will be just, do they have an IP here? No. So we can just do a varchar for that. There we go. And we'll go and save. Here it's getting created, persist it. There we go. Now you'll notice you can create new columns pretty easily. Deleting columns is a little bit more difficult sometimes. All right. Adding columns are easy. Editing a column that already exists sometimes can be impossible. All right. It's best if you think through your stuff at first and you don't have to really mess with your tables after the fact, because databases don't really like being modified after the fact. Adding new columns, pretty much it will always be okay. But when you do anything else like deleting columns or modifying existing columns, things can go really bad really quickly. And usually that requires, depending on the severity of it, will require you to literally make a brand new database from scratch with all your modifications and then transfer all the data over. Or make a new table from scratch and transfer all the data over. This, if you have lots of users, could be a massive issue. All right, so you really want to think through this really well at first. Only way you do that is with time, and no one at an entry level should be making important databases for a big company. All right, without supervision, because that's just going to be some disaster. If we look in here, you'll see our new columns are here. By default, they're going to have the values null. Null means nothing, absolutely nothing. There's nothing in this at all. All right, so that works for us right now. So be aware of this. If you add any new columns and you had, let's say, 10,000 users on your application, they're going to get null by default. Maybe you don't want null in there by default. All right, there are ways to auto set a default value for new columns that you add. All right, so be aware of that. If we want to modify this stuff, we can double click on these record items inside of dbeaver, and we can modify them. So we can say my IP address is 1234. All right, and then created time. We're not going to mess with that because I don't know the format it wants. All right, so there's no physical unique defined here, so I guess that's the one we're missing. Custom unique. Okay, so that's what we need to do here. All right, I'm going to cancel that right now because there's one last step we need to do. And actually, we'll talk about it after the break because it's about time for us to go to break. So during the break, you know, chill out a little bit, maybe mess with making some new tables, right? Mess with making some new tables, maybe make some new columns, add some more data, add some more users to your database here, all right? And when we come back, we're going to be talking about our constraints and indexes, and pretty much finishing up our Postgres database setup here, or our users setup here, because I guess Serial doesn't also make it the default index. You'll understand that here in a second. All right, I'll see you guys in 3 to 5 minutes. Alrighty, you guys. Let us chug along here on our journey. But before we do, let's redo our little intro here, and it's going to be a little different this time because we got the little small window since we zoomed in here. But if you don't know, we are Rootkit, a non-profit organization here in the US of A. Don't go to college. Don't go to any other boot camp. Just come to us so you can learn how to make messed up websites in their smaller form, like this one right here. All right, let me zoom out a little bit. There we go. Get your comp sci cert with us. All right, you can skip college, skip every other boot camp, and just get a job. All right, just get a job and start working in the field immediately. All right, we're the best in the industry for a reason. All right, our certs are gold. Brain farting right now. On top of all this free stuff we're doing, because we're teaching you everything you need to know in 100 days on how to get our comp sci cert. On top of that free stuff, if you go over to our blog, we have our week 10 giveaway going on right now. So you can enter to win some merch. Just click on the green button here and just show that you're subscribed to our YouTube channel, following us on Twitch, etc., and you can win yourself some merch. What is it going to be? I don't know. We're going to figure out tomorrow. All right, we're going to pull it randomly together tomorrow, and we'll see. On top of that, there's links in the descriptions of this video and on the Twitch somewhere that you can go to go here. Zoom out for this one a little bit. To go here, and you can donate to us. We are a charity, so everything is 100% tax deductible. Avoid your tax. All right, I know what the gov does with it. It's no good. All right, you're better just donating it. All right. Avoid those taxes. Donate today. When you donate, you can unlock yourself some certain rewards, like stickers, collab t-shirt, and our epic sweater, which I got on right here. Has the Rootkit logo on the back. Exclusive only during this event. There's only 30 more days left. You can claim one of these. All right. On top of that, we have all donations are matched 1-for-1 for the first 10,000 donations. So whenever you donate $1, it's like you're donating 2. And there are pillars along the way, like if we can potentially be streaming for 24 hours straight, shaving my head here live on stream, and our goal not to reach this goal, all right? Shaving my beard here live on stream. No one wants to see that, all right? No one wants to see that, so we're just going to continue on, all right? Databases. So far, as a recap, we talked about what SQL is, all right? We talked about how SQL has like 10 different meanings. One is an actual language. Another is in reference to a certain type of database, a relational database, which allows you to keep relations. We haven't shown yet how you can go about doing relations in this database yet. But we also talked about how databases are pretty much the same layout as Excel spreadsheets. It's not a coincidence. All right, it's not a coincidence. And databases are effectively smarter text files. All right, you can use a text file for storage of data. That's how most logs are stored. Most logs are just stored in a text file, all right? Even in just normal text format. Databases allow you to be smarter, more compressed, and allow for extra functionality, faster speeds, because they're auto doing some extra stuff on it. But it is still, at the end of the day, text that is being stored in a file, all right? Text that's being stored in a file, all right? So let us continue here. We showed how you can make a table. In Postgres, you have to go through like 20 different folders here to get over to the table section. In the table section, you can make as many tables as you want. So if you're in dbeaver, you can just right click and create new tables. All right. And you create as many tables as you want. Inside of tables, there are columns, which if we click on the data section, you can see the layout of the columns there. All right. Just like an Excel spreadsheet, you can filter you can search. It's very, very fast for searching. Let me revert that. Revert all changes. Yes. Do you want to save changes to the database? No. There we go. So you can see it's just a Excel spreadsheet on steroids, basically. All right, that's all it really comes down to. Excel spreadsheets, though, don't really have built-in optimization for indexing and relations, which we're about to go over right now. So we made this database, and we made this thing called ID, which is attached. And whenever we refer to users, you don't want to refer to users by their names. All right, that's a terrible, 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 a million times over terrible idea. Never, ever do that. All right, why? Well, guess what? It might be shocking to you guys, but I'm not the only Elijah in the world. I know, it's a really cool name. All right, but I'm not. All right, same thing with you, Matthew. Might come to shock to you, buddy, but might not be the only Matthew in the world. All right, so if you were indexing or searching for people based off the name Matthew, and you had 10 different Matthews in your database, you're gonna get 10 different results. That's no bueno, right? That's no bueno. You want to use your ID here. Your ID is going to be custom and unique for every single user. So whenever I say user with ID 10, we want that exact user. What that is, maybe that's a Matthew, but that's the only Matthew I want. I don't want any of the other Matthews, all right? So using IDs for identifying people is best, all right, is best. But how you can make it even better is by indexing on them, right? Indexing on them. What do I mean by that? All right, what do I mean by that? Great question. We talked about binary search trees, right? And we talked about how they can be really fast and they give you lots of speed improvements. Even on really, really large data sets, they actually get faster and faster on really, really large data sets than anything else. You can do that automatically here. And you do that by making an index, all right? But there's a couple ways we go about doing that. Number one, databases work off of keys, all right? You might have seen the thing called here foreign keys. Foreign keys are foreign. What does that mean? They're not from this table. They're from a different table, all right? We can have our own local keys. What are keys? Well, these are different keys from like your normal key where you unlock a car or a house or something. These are the keys that are the quickest lookup. So whenever you're using this database and you're referring to records in here, you're referring them by potentially their ID. That's your primary way of referring to them. That's the keys to your database per se, all right? So how we can make this ID the primary key for our database is if we go over to constraints over here, we can create a new constraint and say that our primary key, right? Our primary key is going to be ID. So we got to check ID down here, right? When we do this, typically on a database, this will automatically add indexing for that item. So let's go and do Control S. It's persistent, and we'll also check here if it has been indexed or not, all right? You can also use constraints for a couple other things. Like for example, if you want email addresses to always be unique per person, you can make it a unique key, which means that every person must have a unique email address, and the database will never, ever, 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 ever allow anyone to have a duplicate email address. This could also be useful for things like usernames. You may not want people to have the same username. You want each one to be unique. You could potentially make that a primary key, but if you're using your ID as your primary key, you can make it a unique key, which means that the database literally will not allow multiple people to have the same username. It will just straight up deny it, all right? So that's a way you can ensure that you have integrity in your data and people don't have duplicates, right? People don't have duplicates. All right, so when you make a key, your primary keys by default should be indexed. All right, so if you go over this section called indexed, there we go. You can see there's our primary key right here, and it's already indexed for us. What does indexing mean? Indexing is the extra smart, ultra epic feature of why we use databases in the first place. Because so far we saw columns and we saw we saw our data laid out here, which is effectively the same thing as an Excel spreadsheet. So why don't we just use an Excel spreadsheet? You could, you totally could. And you really wouldn't get too much extra features out of an Excel spreadsheet to this, all right? Until we made that primary key and primary keys get auto-indexed, right? That's the true power, like that's some of the true power of using a database, all right? So what is an index? An index is using potentially those binary search trees for doing optimizing search results. Optimizing search results. So if we look here, and I know it's kind of small for some of you guys, we can see that our primary key was indexed. What column was that? That's our ID. Our IDs have been indexed. And there's some information here. All IDs must be unique. The database is actively enforcing that. Additionally, you can see that there's this thing called B tree. What is this B tree thing? That's a great question. Can I double click? Okay. B tree should sound kind of familiar. Can you guys guess why? We've talked about trees before. I've mentioned it several times. That's right, a binary search tree, a B tree. This is what it's going to be using, and you can change this depending on the database. Let me see if I click on here. Can I change? Will allow me to change the type. Maybe not. So some databases allow you to change the method that's being used from binary search tree to something else. So by default, this is going to be using a binary search tree. So you guys have already learned about that when we talked about it in C. This by default is going to be using that highly optimized searching tree to index your data. All right, so what's going on behind the scenes in your database is it has the data, effectively your Excel spreadsheet stored off. Right beside it though, it has a binary search tree it's created and saved for you that will allow for hyper optimized search results. They are very, very fast, right? Very, very fast. Faster than Excel spreadsheets will be able to do, all right? This is the real power behind these databases. Well, a lot of the real power, right? So let us continue on here. We have a table called users, right? We have a table called users. But if we want to continue on with maybe our like tweet example, all right, where we finished off, and we just love Twitter, all right? It's full of epic, awesome, positive people, all right? Definitely not a toxic cesspool, all right? So if we want to go forward with that example, maybe we want to make another table here for storing tweets, on our Twitter clone, all right? So we can go about doing that. Let's make a new table here, and let's call this table tweets, right? And in here, we want some columns, all right? By default, I'm telling you guys by default right now, pretty much always make an ID column. All right, always make an ID column. As you use databases more, you'll learn when you don't need to do this, but by default, it's always safe for you guys to just make an ID column. And we're in Postgres, which means this needs to be value serial. All right, so let's click on serial here. And this can't be null, so we're gonna click on not null, all right? And click on OK. Additionally, if we right click on this, this needs to be made into a primary key, which is a constraint. So if we right click on it, you'll see something here called new constraint from selection. We'll click on that, And this should be our primary key. All right, it's checked right here, primary key. We'll click on OK. All right, so we're set up. Our ID is completely set up now. Next, we're going to want to make something maybe called their tweet or their tweet text. So this is when they actually, or the actual stuff they put in their tweet. All right, that shouldn't be null either because they should be submitting something with some data in it. So we'll go and click on not null. Again, this is up to you on how you want to do your data storage. Maybe we store the time that they did their tweetings, right? Their tweets. So let's go ahead and type in T and find time, all right? And next, we need to know what user did these tweets. What user did these tweets? So what should we do in here? Should we just make a column for like users and then like put their username in there? No, 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 no. This is a SQL database. You do not do that. We have something we can refer to get the entire user's information. Something that we know is guaranteed going to be unique and is going to be referring to that user. It is guaranteed to be there. It's guaranteed to be one for one. That's the user's ID. So let's just make another column here called user ID, where we're going to store the user's ID of who tweeted, all right? So user ID, and this is going to be not a varchar, this is going to be an integer value. So we'll click on int, and we're going to say not null because there has to be a user that tweeted. So we'll click on OK. And this looks like a pretty decent table here for storing tweet data, right? So we'll go and do Control and S, and you'll see it's going to create our table here. Please spend time looking at this over so you can start learning a little bit of the structure of SQL. We'll go ahead and persist that. This has now been created. This has now been created. If we go over to the user section, we can see we have a user in here with an ID of 1. With an ID of 1. So if we want to make a tweet, let's make a tweet here, right? Let's make a tweet. So if we go to the table right here and right click and go down to generate SQL, and we know when we want to add something, we have to insert new data. So if we click on insert right here, you'll see we get that, what do you call it? We get some setup here for us for inserting a new tweet. It's going to give us the raw SQL. We're just going to go ahead and copy that, or you can click the copy button right here. I still left the tab open here from earlier, but if you don't, just click on this SQL button. All right, so you can see this SQL page. I'm going to delete this stuff and paste that SQL instead in here. As a review, this SQL is going to insert some new data into public.tweets, so schema.table, our tweets table. It's going to insert data into tweet text, time, and user ID. All right, let's go ahead and make a tweet here. All right, our tweet's going to be like, did this work? Question mark. And we won't enter a time right now. And then our user ID, we know I'm tweeting this. I am user ID of 1. So this should not be 0. This should be a 1. This should be a 1. Let's go ahead and run this. All right. And when we run this, it's going to give us a beautiful error. Invalid syntax for our time. Oh, now we gotta go look up the format of time. Can we does it allow for something like time dot? Okay, let's look up what the default format of time is for Postgres SQL time format. Can I just copy this? Let's see if this just works. So I'm gonna just paste that in there. And then we run. Look at that. All right, that worked. Right, that worked for our time format. So time is literally just the time, not the date or anything like that. It's just the time of day, right? So that might be a little bit of issue for your program. You might not want to use time, right? You might not want to use time. You might want to use something else, right? But we ran that. We know it worked because down here it says it updated one row. It said it ran this stuff and it started here and it ended here. Additionally, if we go to the tweets table, we can see in the data section whether it's here or not. And it's here. If you don't see it here, make sure you click on the refresh button down here because you may need to refresh your table. We can see our tweet is now gone here. Our tweet has an ID that was automatically made for it. We see there's some text for it. There's a time on when it happened. We don't know what date it happened on, all right? So that's an oversight. And this is the user that did it. I know it doesn't make sense at first because it's just the one. But the point is the one is coordinated with an ID on another table. That's the relation part of the relational databases, all right? That's the whole point of these types of databases is the relations, right? We made a relationship between the users table and the tweets table, all right? So we don't need to copy data. It's very, very dry this way. Now, this is a half-done relationship, right? This is a half-done relationship. And I'm going to show why here in a second. Before, though, are there any questions? Are there any questions? I'm gonna wait like 30 more seconds here, see if there's any questions that roll in. If not, we're gonna go ahead and chug along here. All right, I don't see any questions. So if you do still have one and you're typing it out, go ahead and type it out and I'll be checking chat as we continue forward here. So our relationship has been made halfway, right? It has been 100% made in the sense that we can look here, we can see user ID of 1, and we can go to the user table and see that it is right here, user ID of 1, and it's this Elijah Harmon guy, all right? We can do that. The database, though, we haven't optimized the database to its fullest ability, right? It has some extra features to make this even more connected to a sense where even the database knows this. Because right now the database doesn't know these tables have a relationship. Only we do because of the data that's in them, and we can imply, that they're connected. But the database doesn't know. And the database loves optimization and loves making things fast if you tell it to, which we want to tell it to make this connection very, very fast. So how we can do that is if we go over to the tweets section and we go back to properties here, there's this concept of foreign keys. We have one of those right now. Foreign keys, again, are keys that are not a part of our database, right? Not a part of our database. If we look, we only have one key. That's our primary key. And that primary key is for this ID value. We have no key for the user ID. But user ID is a key on the user table. See this ID here for users? The user ID? That is the primary key here. So we can link these two together utilizing foreign keys. If we click on the foreign key section, you can see there's no foreign key set up right now. It has no clue that both of these are connected to each other. So if we right click on it and say create new foreign key, we can say that we want to refer to the reference table the user table, all right, the user table and the user's primary key, right? The unique key right here, the user's primary key. So if we look here at the bottom, it's kind of, the layout sometimes can be kind of confusing, all right? But it's easiest if you just click on column and click on the drop down, and you can kind of see here. So the first section here, the first column here, is going to be for your current table that you're on, which we're on the tweet table. We want the tweet table's user ID, right? The user ID here to be related to the, and it's already done. There we go. It's already done it. We want the user ID here to be related to the ID of the reference table, of the users table here, because the reference table is the users table, and I just clicked on that and messed it up. So now the database will know that the user ID and the ID over on the users table are connected, right? Are connected. There's so much connected, in fact, that we can now get extra functionality. For example, on delete here. What does this mean? Well, when you delete the user from the database, you can actually have it do effects to the rest of the database. You can have it do a cascading effect, which means that if you were to delete a user on your database, it will automatically delete every tweet that was associated with them, which might be really cool if you want to clean up someone from your database. Or maybe you don't want someone to be deleted if they've interacted with your product before. You can set up restrict. Restrict means that when a user gets deleted, if they've tweeted before, it will stop them from being deleted. It will not allow there to be any deletions of the user because they already have data in this table. And there's other stuff you can set up, like making it null. Same thing goes with update, all right? If anything of the user were to update, you could potentially auto update the ID on this column, all right? Not really something that would be as useful as delete, but this is the extra functionality your database can give you, and you can set it up however you want. I'm going to do no action on both because we're going to keep this simple right now. But if we click on OK, you'll see it now made this connection. And if we click on Control S or our save button right here, you can see the little SQL syntax here for making this. All right, let's go and persist it, and things have been saved. And we can actually see this kind of be reflected if we go over to the data section. When we go to the data section now, our spreadsheet here for tweets has a little new icon right here by the 1. This is the really cool interaction that you get, and that extra speed, that extra everything the database will give you. Now that this is fully connected, before it was half of a relationship because we knew it was a relationship, but the database didn't. So we would need to imply that. But now we've completed it. We've told the database we want this to be a relationship. And now that it knows, we can click on this, and when we click on this, it will automatically pull up here on the side more information about who this user is. Additionally, there's this little icon here, and if we click on that, it will automatically take us to that user so we can see who that user is. Additionally, any queries that we make to the tweets, can I go back to the can I click on it? Go back. No, go back. Did I press back? There we go. Whew. Any queries we make to this table will have ultra fast results for resolving the user ID. All right, resolving the user ID, aka getting the information for the user itself. Because how many times have you looked at things like Instagram or Facebook or Twitter and seen a tweet? Usually when you see that tweet, you'll see their icon photo, their name, their like at tag that you can do to like at them in a message. Even though those look and appear to be one single whole item, it's an illusion. It's an illusion that the developers have made for the user. In reality, in the back end, all of those pieces are going to be potentially on a bunch of different databases, and they're stitched together with these relations and then presented to you in a big query where it queries a bunch of tables and meshes all this data back together and then gives it to the user so you can see it as one holistic photo, right? One holistic photo. So let us see here. Any questions so far? Any questions so far? I think that's about where we'll end it for today. Please ask any questions you guys have before we end it for today. So as a recap, as you guys bring in questions, as a recap, we talked about databases, SQL databases in particular, how there's a bunch of them. Each one will be using the SQL language. They may have slight alterations in the SQL language, but in total, they're pretty much going to be the same. We showed how to make tables. We showed how to make columns in those tables. We talked about the different data types that you can have, in particular to Postgres. Then we talked about keys, which are going to be underneath the constraint section. And keys, anything that's a primary key, is automatically going to have an index made for it, which means that you will automatically get that super ultra high speed for searching using a binary search tree, right? It does it automatically for you. Additionally, you can use relations in these databases utilizing foreign keys to make ultra fast queries and connections across tables. So that's pretty much all we covered is today, which was a lot of creation. And I guess we covered how to add data to these databases, right? We showed how to add. We didn't show how to do any searching or looking up, which we'll go over tomorrow, right? We'll go over tomorrow. And we'll make some more tables and get some more practice with everything. I see, don't have any questions, but this all seems super useful. Not sure where I'd end up using it, but very neat to learn anyways. This is extremely useful. Any job that you want will be using a database, right? They will be using a database. Every service you've ever interacted with uses a database. So you gotta get familiar with using a database because it's quintessential to how the world works. We'll go over examples here on in the coming days on how to use these databases, because you may need to use a database in your project for the practical exam for getting our cert. You may, maybe you know, maybe you do, who knows, right? Regardless, this is a required item on our certs to know, which is SQL databases, right? Let us see here. We've given classes before on some of the pro features of databases. These are the basic features, right? We're not going to be talking about triggers, rules, policies, partitions, stuff like that, because it's not needed to get your cert. All that's needed for you for your understanding of SQL databases is tables, columns, keys, foreign keys, and indexes, right? Which we've covered them all today. As your guys' challenge, make more databases or make more tables. Make more tables, mess with them, add some data to them by hand. All right. We haven't showed you guys how you can connect this to your code yet. Don't worry. We're going to show that. Right now, we're just focusing only on databases. All right. As a stretch goal, you are more than, more than okay to go look up how to connect this Postgres database to your code, right? Go ahead, get a head start. Go mess around with it. Just mess around with it. That's all you guys need to do right now is have fun with it, right? Duplicate some things. Maybe you're really into Instagram or really into YouTube or really into, I don't know, a game, all right? Maybe it's Fortnite or whatever. Try to duplicate maybe the data they're saving. like the point systems that they have, or what their rewards they have, or the drop tables, the loot tables they have. Try to recreate those tables inside of the database. All right, just try to make some stuff. All right. All right, sweet. That's all I got for you guys today. Tomorrow we'll continue this journey. If you have any other questions, feel free to drop them into the 100 Days of Rootkit chat. And I'll see you guys tomorrow on the next one.